Hi everybody, Mr. Kalala here. This week we're going to get into talking about probability. This video is going to focus on what's called theoretical probability. You may notice that is a form of the word theory. Remember that when something is in theory, it's kind of what we expect to happen. Doesn't necessarily mean it's definitely what will happen, but it's what we expect to happen. You'll see a little bit more about that later in the video, but let's start taking a look. So the first thing you need to focus on is understanding that probability is always going to fall somewhere on the number line between 0 and 1. Okay? And to understand that, you need to think about what we talked about when we talked about percents earlier in the year. So if we're at 0, we're going to think of that as 0%. You should know that 100% is 1. So when we're talking about the probability of something happening, it's got to be somewhere falling between 0%, meaning no chance of it happening, or 100%, meaning like it's definitely going to happen. It can't be anywhere else but in between those two things. So what we want to do is we also want to look at 1/2, which you should know is going to be 50%. And we want to start thinking about this kind of spectrum of how likely something is to happen. If something is between 50% and 100%, so if we look basically from here over to 100%, we call that likely. So if something is above 50 but below 100, we consider that to be likely that is going to happen. So if the weatherman says that there's a 75% chance of rain, that would be considered likely. We would expect there to be rain. Okay? Let's get rid of this. Let's focus on the other side of it. So let's look from 50% down to 0. Okay, that falls in what we call unlikely event. So if the weatherman says that there's a 20% chance of rain, it's unlikely that it's going to rain. It could rain, there's a chance, but it's unlikely because there's only 20%. That means the other 80% is that it won't rain. So again, from 0 to 50% is considered unlikely. Now, in between 0 and 50 and 50 and 100, we have 1/4 and 3/4 you can see on here. I would hope you know that that's 25% and 75%. Okay? There's a couple of other things labeled on here that I want to draw your attention to. 50% is considered equally likely. So, like flipping a coin, you're equally likely to get either a head or a tail. So, 50% equally likely. Okay? If something is 0%, we call that impossible. It can't happen. Now, it's very rare for something to be 0%. Okay? Even if there's the slightest little bit, even if it's only a 1% chance, it's still possible. So in order to be impossible, it has to be a 0%. Okay? So an example of that would be like when you're, say, rolling a dice. When you roll a dice, you can get a 1, 2, 3, 4, 5, or 6, and that's it. So if I said, what's the probability of rolling an 8? That would be 0%. That's impossible. There is no 8 on a dice. There's only a 1, 2, 3, 4, 5, or 6. Okay? So 0% is impossible. On the very other end of the spectrum, 100%, that's certain. If it's 100%, it is certain, meaning it is definitely going to happen. There's no ifs, ands, or buts about it. Okay? So just to recap quickly, from 0 to 50%, we call that unlikely. It could happen, but it's unlikely. From 50 to 100, we call that likely, meaning it's probably going to happen. It's not definitely, it might not, but it's likely to occur. 50% is a 50-50 shot, meaning it's equally likely to either happen or not happen. Okay, 0% impossible, and 100% certain. All right? I want to quickly just make sure we remember how to go from a fraction to a percent and a percent to a fraction, because we're going to see a lot of those with our probability. I'm just going to pick a really, really simple one like 3/4 to talk about, just to recap for everybody. Some of you have no issues with this, I'm sure, but in case people do, remember that all you need to do is take your numerator divided by your denominator. So if I say 3 divided by 4, okay, 4 cannot go into 3, so I'll add a decimal. 4 goes into 37 times. I go ahead and multiply and subtract. I'll bring down another 0, and 4 goes into 25 times. So 0.75, remember you go ahead and you move that decimal over, and I would get 75%. Okay? You also can turn a percent back into a fraction by simply just putting it over 100 and then simplifying it. So that would simplify back to 3/4. We're going to be going back and forth between fractions and percents quite a bit when dealing with probability, so keep that in mind. All right, when it comes to probability, you want to think about what's called an outcome. Now, outcomes are all the possible things that could happen, okay? And what we want to do is when we create a probability, we want to look at what I have over here on the right, which is the idea of favorable outcomes over total outcomes. Now, favorable means like what you want to happen. So if I'm looking at this jar of marbles here, and let's say I want to know the probability of getting a blue marble. So if I want to know the probability of getting a blue marble, there's only 3 blue ones. So, and there's 20 total. So my probability would be 3 over 20. Because the favorable outcome would be getting a blue one. There's only 3 of those. And then the total outcomes is 20 because there's 20 total marbles. Okay? I could then turn that into a percent by just doing 3 divided by 20. 3 divided by 20 would be 0.15, which is 15%. So for every color, I could do the same thing. For red, I could say, hey, there's 7 red marbles, so the probability of getting a red one is 7 out of 20. 7 divided by 20 ends up being 35%. And last but certainly not least is the green ones. There's 10 green ones, so the probability would be 10 out of 20. I would hope you know that that's 1/2. You should always simplify these whenever you can. So it simplifies to 1/2. And that, of course, is 50%. So all you have to do to create a probability is make a fraction, a ratio, of favorable outcomes over total outcomes. And again, when we say favorable, we mean having what you're looking for occur. Okay? Now, I want to make sure we're clear here that when we're talking about probabilities, if I take all the probabilities in a given situation and put them together, they should always equal 1. Because remember, 1 is 100%. So if I bring back those probabilities from the last slide a second ago, remember we said that blue was 3 out of 20. Red was 7 out of 20. And green was 10 out of 20. Well, if I add all those together, I get 20 out of 20. I would hope that makes sense because you're going to pull either a blue, a red, or a green. That's the only options. So there is a 100% chance that you will get a blue, red, or green. That is what I get when I add all of those together. And sure enough, if I took the 15%, 35%, and 50% and put them all together, that would equal 100%. So whenever we are talking about probability, they should all of your possible options should always end up equaling 1, which is 100%. Let's talk about spinners. Spinners are a very, very common thing that you're going to see in probability. You may have probably seen them before. This is just an example of a spinner. You can see there's 3 sections labeled A, B, and C. The idea is you would spin it, much like you might have on a board game, and we can tell the probability of landing on any given section. So if I want to know the probability of landing on B, since there is 3 sections, I would say that it is 1 out of 3. Pretty simple. If I said what's the probability of landing on, let's say, B or C, well, that's 2 of the 3 total sections. That's it. The key here, though, in understanding this spinner is understanding that these sections are equal. We have equal sections. all of the sections on that spinner are the same size. If they're the same size, you can go ahead and create your probabilities. If they're not the same size, like this one, we need to do something first. If you look at this spinner, if I say what is the probability of getting red, you can't say, hey, there's one red section out of 3 total. That wouldn't be correct. I would hope you can look at this and see that half of it is red. So the probability couldn't be 1 out of 3. What I need to do in this sort of situation is make sure that I first make equal size sections. So what I'm going to do is I'm just going to take this and I'm going to separate the sections to make them all equal. You may notice I now have 1, 2, 3 red sections, 1, 2 blue sections, and 1 green section. So now, if I find the probabilities, I would say, and by the way, that's obviously 6 total sections, so I would say that the probability of red is I have 3 red sections out of 6 total. That simplifies to 1/2, which makes sense because half of the spinner is red. If I wanted to find the probability of blue, that would be 2 of the 6 sections, so 2/6, which simplifies to 1 out of 3. And the probability of getting green is there is 1 green section out of 6 total. Again, I want to point out 3/6, 2/6, and 1/6 equal 6/6. They should always equal up to 1 whole. Okay. Let's get a little bit into this idea of what is expected versus what is actual. And this is what I mentioned earlier at the beginning when we consider theoretical probability. You can see here I've got a quarter. A quarter has a head and a tail, just like all coins. So when I flip a coin, there is this probability, and we would consider it to be what we call 50-50. Okay, 50-50 means, hey, I can get either a head or a tail. So when you're flipping a coin, you would expect half the time to get a head and half the time to get a tail. Anyone who's ever flipped a coin knows that that's not always necessarily what happens. Let's say that I flip a coin 10 times. So I could say 10 flips. Probability says that I should get 5 heads. And I should get 5 tails. That's not always the case. I might get 7 heads and 3 tails, or 4 heads and 6 tails. I could get any different combination. Now, when you're only doing it 10 times, that's not a very large kind of sample of flips. So the more you flip it, the closer and closer you get to having it be 50-50. So what we mean by that is if you were to flip it 10 times, you might get 10 heads or 10 tails. It's possible. But if you were to flip it 100 times, you're probably not going to get 100 heads or 100 tails. That would just be almost impossible. So if you're going to flip it 100 times, you would expect it to be a little bit closer to half heads and half tails. We can look at this again with a spinner. Again, at this spinner, I have 4 equal sections. So for any given color, I could say that the probability is that that color has 1 out of 4 sections. So let's say I was going to spin this spinner 100 times. That means I should get each color 25 out of 100 times, because those are equal to each other. If I spin it 100 times, that's not necessarily what's going to happen. Let's take my 4 colors here. So red, yellow, green, and blue. So again, if I spin it 100 times, maybe I get, let's say, I don't know, 23 red, 24 yellow, let's say 27 green, and maybe it'd have to be 26 blue. So you add up all those spins, and they do equal 100. It doesn't mean that I'm definitely going to get 25 of each. Now notice all those numbers, they're all close to 25, but they don't have to be exactly 25. We expect them to be close, though. It wouldn't make sense if I spun it 100 times and got 85 red. That just wouldn't happen. The probability it doesn't bear that out. So we would expect to have close to 25. I might get 30 or even 35 of a certain color, but not that far deviating from the 25 that I expect. Okay, so I hope this helps. Remember, you're going to create some fractions, some ratios to show your probabilities. It's always going to be the favorable outcome over the total possible outcomes. And remember to simplify them whenever possible. Hope this helps. Good luck.